This is the second lecture of vector analysis. Now suppose I give you one question that you have been given vector A and B equal in magnitudes. Okay, A and B are equal in magnitudes with proper scale. You have to represent A plus B, then A plus 2B, A minus 2B, 2A minus B, and B minus half A. Okay, so A and B are equal in magnitudes. Magnitude means the length of the vectors are same. Okay, if A and B are equal in magnitudes, you have to show what is A plus B, and they are perpendicular to each other. Okay, A and B are equal in magnitudes, and this will do. A and B are equal in magnitude. So suppose this is A, this length, and let us say this is B, and they are perpendicular. It is given. Okay, this is given. So A and B are two vectors. They are perpendicular and equal in magnitude. See, two vectors can be only equal if they have same magnitude and direction. So you can see that their magnitude is same. Let us say this is 5 centimeter, this is 5 centimeter, but direction is along x and this is along y. So they are not equal vectors. Now A plus B, as you guys can imagine, if I can represent two vectors by adjacent side of a triangle, then resultant it is drawn from the tail of the first vector to the head of the last vector. So this is going to be my resultant, and that will be A plus B. Now what about A plus 2B? So if you multiply B with a scalar, then 2B will be a new vector which is double of the length than B. So this will be my, let us say, A vector. B is this, so twice B. So A plus 2B is this. Okay, now one thing, they are perpendicular, and I also told you the angle between two vectors are measured where the tail coincides. Okay, so actually if I draw them this way also, this is A, this is B, right now, then using this is the angle between them. Or let me explain it here using parallelogram law. This is B, this is A, so A plus B will be this only. Okay, now this AB angle is 90 degree. Okay, this angle, of course it is 90 degree, but actually you have to measure the angle where the tail coincides. So using parallelogram law, I can visualize the tail thing, and this is the angle 90 degree between them. Same goes for this also. I can draw a 2B vector here, and this is A vector. This angle is 90 degree. Okay, where the tail coincides, and of course this is the resultant. This is A plus 2. Now if I have to draw A minus 2B vector, then how we do it? So a negative of a vector is the same vector having same magnitude but opposite in direction. So this is my A, 2B was in this direction, so if I draw a vector minus 2B will be in this direction. So again they represent adjacent side of a triangle taken in order. So resultant will be this will be A minus 2B. And what about 2A minus B? A is this, so 2A is this, double of this. 2A minus B, B was in this direction, so minus B will be the same vector but going in opposite direction. So this will be minus B, so 2a minus b will be this vector, and the last b minus half a. So b is this, a is this, half minus half a, half of this. So I am putting it here. This is minus half a. Okay, this is going in this direction, this is going, this is minus half of a. So b minus half a will be this. Okay, these are the way to draw this number, this results. Okay. Now we are going to talk about most important part of vector, that is called projection of vector. Projection of vector. Okay, also called components of vector. And also called resolution of vector. Now this is going to be the most important part of vectors, by which we solve all the problems or most of the problems in mechanics, in physics. So to understand the concept, just imagine this scenario, that you have a trolley bag. Okay, you have a trolley bag which is not heavy, and this is the handle of the trolley bag, this is the ground. Now the bag is not very heavy, of course you are pulling it, so you are applying force in this direction. I will represent now force by a vector. Then how come the trolley moves in this direction? Okay, I will write displacement S. Okay, is in this direction. Now it turns out that the trolley is moving in this direction. Of course it is not moving along the direction of force, right? No? If the trolley moves along the direction of force, then it will just lift and it will start moving in space, right? No? So it is moving along ground, so it seems that somehow you are applying force in this direction also, x direction. Okay, and somehow you are applying force in this direction also, y direction. We'll talk about it. Now the same idea. So this is the force you are applying. Now at the tail of the vector, this is my force vector, at the tail of the vector you draw x-axis and y-axis. Now let us say this angle, it is making theta with horizontal. Okay, so suppose this is ground, this is a parallel line to the ground, this angle is theta, so this angle is theta. Now what you do, you drop a perpendicular from the head of the vector. So this is one perpendicular on x, and I am going to call this force to be Fx, and let us drop a perpendicular on y, and I am going to call this force to be Fy. Now it turns out that how you find components of the vector. To do that, if you know the vector, then what you do at the tail of the vector, you draw x and y axis. Then from the head of the vector you drop two perpendicular, one on x and one on y. Now this is called x component of force. Okay, this Fx is called x component of force, and Fy is called y component of force. We'll return to it. Now let us say, okay, now this scenario you guys can remember, but this is general. Okay, now let us say that this is parallel line. Let us say our force is like this. Okay, let us say this is x-axis and this is y-axis, and it is making some different angle. So again you drop a perpendicular. This is your x component of force. You drop a perpendicular here. This will be y component of the force. Now from the result, let me say this is angle is theta 1. You can see that this x component will be very larger. X component is this much and y component will be this much only. So here x component is quite larger than y component. Now let us take one more example. Suppose this is my x-axis, this is y-axis, and you found that the force is applied in this direction. Let us say like this. Now what is its x component and y component? So let us say this angle is theta 2. Again you drop a perpendicular. This is its x component. You drop a perpendicular. This one is y component. Now you can see that y component is larger than x component. So this is the way we resolve this is called resolution of vector. But let us go to D part. This once I resolve the vector, then you can forget about it and you can imagine that Fx force is acting in this direction and Fy force is acting in this direction. Okay. Now how we represent that? Now if you guys remember triangle rule, then and in the last lesson I told you that along x-axis I cap is the unit vector and along y-axis j cap is the unit vector. So from this result we interpret like this, that I am applying Fx magnitude of force along I direction, or along x-axis I am applying Fy amount of force along j direction. Now this component is a scalar quantity. Okay, this Fx is not a vector, it is just a magnitude. I multiply with a vector. This is unit vector, just used for direction. Now this you can call it force along x direction, and this you can call it force along y direction. Try to understand it. These components are scalar quantity. Okay, components are just numbers. Okay, so suppose this is something 10, then it will be some number. We'll find how to find that number. So the same interpretation can be that I am applying Fx force along I cap and I am applying Fy force along j cap. This can be called force along x and this can be called force along y. Now using triangle law, if this is one vector Fx and this is one vector Fy, let us say, and this is magnitude Fx, vector is Fx vector, then you can see this is the resultant. I can write these two vectors represent adjacent side of triangle, so the resultant F can be written as Fx vector plus Fy vector. Now this Fx vector is nothing but Fx I cap, this is the number, fine, and this is Fy j cap. Now this is one representation of it. These are same representation. Now let us use Pythagoras theorem or triangle law here. So in this triangle you can imagine this triangle, this length is F, this length is Fx and this length is Fy, this is theta. Now if I find cos theta, you can see cos theta is base by hypotenuse, So it will be fx by f, and this will give me fx equal to f cos theta, right? And if I take this triangle, okay, for general reason I am taking this triangle. This is also same thing. This is 90 minus theta, right? This angle. This is fy, this is fx. So in this triangle, if I find cos theta, I get this. If in this triangle I find cos 90 minus theta, okay, cos theta only in this triangle, and it is base by hypotenuse, it comes out to be fy by f, and this will give you fy to be f cos 90 minus theta is sine theta. Now the same thing, f vector, can now be written as f cos theta I cap plus f sine theta, or let me write cos 90 minus theta j cap, which is same as f cos theta I cap plus f sine theta j cap. Now what is amazing, that this relation, let us say this is A, this is B, and this is C, all are same, okay, all are same relation. Now let us try to understand again what is component. Now as I told you, component of a vector is a scalar quantity, okay. When you multiply with a unit vector which gives direction, then it gives you a new vector. Now how we find what is fx? It turns out that fx is nothing but x component, that is fx is f times cos theta. That means, see, if you know the vector, this is length f vector, and if you know the angle theta, then it is the vector times the cos of the angle between vector and the x-axis. So what is x component of force or x component? If you know the vector, let us say f, and if you know the theta, then you multiply that length of the vector f with cos theta, that will give you x component. How to find sine component, or sorry, y component? Y component is again given by the same thing only. Fy is, so you are finding how much is this, so it will be f times what angle it is making with y axis. So this is 90 minus theta, so y component is vector times cos of this angle, okay. So vector length time cos of the angle which it is making with y axis, and it turns out to be f sine theta. But this sine theta is just a trigonometric change, okay. If you know the thing, if you know the vector and if you know the angle with the axis, then you can find different x and y component, okay. Now let us take two more example. Let us say we have, this is suppose force F1, this is force F2, and let us say this is force F3, okay, and let us say this angle is 30 degree and this angle is 60 degree. Now the question is, find the x and y component of each forces. Okay, now these are three forces, and let us say that they are acting in this way with the angles. You have to find x and y component. Now since we have three vectors, let us take one at a time. Concentrate on f1 vector. Now at the tail of the f1 vector I have drawn y-axis, and this is my, okay, let me do it properly. So I want to find component of f1, so what I will do, I will draw a y-axis and I will draw x-axis. Now if you remember, what angle it is making with x-axis? It is making 0. What angle this is making with y-axis? f1, it is making 90 degree, right? Now so f1 x component, force 1 x component, is the magnitude of the vector, which is f1 times cos of the angle which it makes with x-axis, cos. So this is making 0 degree with x-axis, so its component will be cos 0 degree, which is f1. Now what is f1 ka y component? f1 y component will be the force, the vector f1 times the cos of the angle which is it is making with y-axis. So how much cos of the angle it is making with y-axis? 90. It turns out to be 0. So you can see that is obvious, because f1 is particularly acting only along x direction. So this is the component of f1. Now let us tackle component of f2. So this is my f2 vector. If I want to find its component, I will, at the tail I will draw x-axis and y-axis. Now I can draw a perpendicular here. This is its x component, f2x, and this will be f2y, right? Now what angle it is making? 30 degree, and this is 60 degree. Now if you ask what is the x component of 2, then f, okay, so f2x I am finding, so it will be the magnitude of the vector, which is f2, times cos of the angle it is making with x-axis. So cos 30 degree. Cos 30 degree is, I guess, root 3 by 2. So f2 times root 3 by 2. This will be its x component. Now what will be y component? f2y. If you see this, then it is y component will be the length of the vector, which is f2, times cos of the angle between the vector and the y. So cos 60, cos 60 degree is half, so this is f2 by 2, cos 60 is half. So this is x component and y component of f2. Now let us talk about f3. So again, if I have to find the component of f3, this is my f3 vector. Then at the tail I will draw x-axis and y-axis. Now you can see f3 is making 90 degree with x. Now what is f3x component? It is magnitude of the vector times cos of the angle of the vector which is making with x-axis. So cos 90, which is 0, cos 90 is 0. Then what will be f3y component? It is a vector times what is the angle it is making with y, cos of that angle, that is f3 times cos 0 which will be F3, and you can see that it is acting along that direction only. Now it turns out that in mechanics this is very, very important. Okay, now let me try to explain you the importance of vector in circular motion. Okay, so in circular motion the particle is going in a circle, so at any time it can be present anywhere, right? Now so it is here, 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 here. Let us say it is rotating it like this, uniform circular motion. Okay, it is rotating with constant speed. Let us say the particle is here at any time. Now as the particle is rotating, the radius of the circle is same. Now suppose it starts here, and after some time, after time t, okay, it reaches here. So if I draw a vector and write it r vector, this is the position vector of this particle p, and let us say it is making an angle theta. Then if I drop a perpendicular, then it will be, this will be the x component of r, and if I drop a perpendicular, this will be y component of r. Now if you do this, then you will find out that the x component, okay, is nothing but r x will be r cos theta and ry will be r sin theta, right? Now so this r vector, position vector in circular motion, uniform circular motion, now this theta is function of time. Okay, so r vector can be written as r cos theta I cap plus r sin theta j cap. Now in mechanics it turns out that resolution of forces, resolving of forces is very important. One more example let me give you. Suppose there is a inclined plane, okay, and this angle is theta. Then if I have a block here, its weight acts perpendicular to the earth. So this is earth, this is mg, right? Now if I draw, this is my x-axis, this is my y-axis, and I want to resolve it, this is my minus y-axis, this is my minus x-axis, it turns out that this angle is also theta, and this component becomes mg cos theta and this component becomes mg sin theta. I will talk about this and more in the next video. Okay, and thank you. I will see you guys in the next class.